Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is island parameter. So you are given a grid representing a situation where there is an island surrounded by water. Okay, so grids, if grid cell is 1, it means that it is land, and if it is 0, then it means that that portion or that cell is containing water. So grid cells are connected horizontally and vertically, not diagonally. The grid is completely surrounded by water, and there is exactly one island. Okay, and it is mentioned that the island does not have any lakes, so you will not be having any water body inside the island. Water is only present outside the island, so means that water inside isn't connected to the water around the island. Okay, so one cell is a square with side length which is equal to 1. So side of each cell is of side length 1, and the grid is a rectangular grid. Width and height do not exceed 100. Okay, so determine the parameter of the island. Okay, so this yellow portion, as you may be able to see in this picture also, is the island, and outside the boundaries of this whole grid there is a water there also. Okay, so if some of the regions are lying just on the boundaries, so you will also count those in parameter. So you have to return what is the total perimeter of this whole island, and that is the thing that we have to do. Other than that, before thinking of an approach, let's have a quick look at the constraints. So the row and columns in the grid is of order 100, and each entry in each of the cells of the grid is either 0 indicating water or 1 indicating land. Okay, so there is exactly one island in the grid. Okay, so this is also part of constraints. So let's see how we can solve this. So for that, let's copy one of those examples that were provided to us. So let's copy this one. Okay, so what we will be doing is, if we are visiting a cell which is right now marked as land, or if your current cell, let's say you are visiting a cell with coordinates r and c, where r is the row and c is the column. Okay, so if it happens that the cell is having 1 stored there, or it means that it is a land, or you are visiting one of these brown boxes, then you will check for the following thing. What is the thing that you will be checking for? You will be checking that whether one of the two things, uh, both of the things actually. So either this one of the sides of this particular cell, let's say you are in this cell, is either at the boundary of the grid. Okay, or it should be the case that one of side is adjacent to a cell which is having water. Okay, or adjacent or touching the cell having water. Okay, only then it will be counted in your perimeter. So you will be having another variable perimeter initially set to 0. Whenever you will encounter one of these two situations, either this one or this one, you will increase your perimeter. Okay, you will increase it, and at last you will be returning your parameter. That's pretty simple. And how you will be doing the check that you are at the boundary or adjacent cell is having water? For that, you will try to move in four directions from the current cell. Okay, so you will try to move in either of all of these four directions, and while moving in these directions, if you are finding out that if moving in this particular direction you can see that we are going outside the boundary of the grid, then you will say that you are at the boundary of the grid, and it will contribute to the overall parameter, that particular side. Okay, and so if you are going in upward direction, so the side which is facing upward is contributing to the parameter. Similarly, we will check for all four of these. Okay, and yeah, this is the logic. And let's have a quick look at the implementation also. Things will be more clear there. So I mean the check that we are doing, and we will also talk about the overall complexities. You know, the solution that we have implemented will be having in terms of space and time. So let me quickly copy. Okay, I don't know why two instances of board were open at that time. Anyways, let's take the code to our board. So this is the code. I think it will be great if we are able to copy this image also over here. So let's try to do that. Yeah, so image is also here. Okay, so what we are doing is, from each cell we are trying to move in these four directions. Which are the what are the directions? These are the four directions. Okay, so you can say that for each land containing cell, we are moving in for try to move in four directions. Okay, try to move to see basically that which of the boundaries of the current cell will be contributing towards the perimeter. So you will be having a variable set to 0, which is parameter that you will be returning as part as your return value from this island parameter function that you are required to complete. And these are the four directions that you can move. Basically, if you are at a cell and you are considering it 0 0, the origin, so you can either go in, if you are considering it as a xy plane, so either you can go in this direction, which is 0, and basically it's 1 0. Okay, and you can go in this direction also, it's -1 0, or you can come downward, which is 0 -1. Okay, and you can come you can go above also. So this is the coordinate system that I was considering. I mean, if you are moving one cell down, then you will obviously considering it increase of as a increase of row. So okay, these are the four directions, just to give you a rough idea. Whether those were exact coordinates or not, that is a different matter, but I hope you got the idea how we are moving here. So then we will be doing just a quick check for the land containing cells. Okay, these are land containing cells. uh you know if the current cell is a land containing cell, then you will do the following thing. You will check, you will try to move from this cell to all four directions, and you will check if it is safe to move there. You will only move to a cell uh, and say that it is safe to move if that cell is having land. Okay, and if that cell is not having land, or if you are when you are taking one step further, you are at the very boundary and you are moving outside the boundaries of the grid, then you will say that it is not safe. Okay, so these are the conditions of uh, you know our move not being safe. So if you are resulting, your one move is resulting uh, you to go outside the boundaries, then it is not safe. So this is outside the boundaries, outside grid boundaries. Okay, and yeah, these two are nothing but these two are also outside grid boundaries. Okay, and that is the check where we are saying that okay, this one is containing water, the very adjacent cell. So these were the two conditions that we were checking for. So either we are moving outside the grid boundaries, or the next cell or the adjacent cell is containing water. Okay, so either of these two conditions, either of these two things comes to be true, or both of them, not both of them actually. So then in that case you will be returning false, otherwise you will be saying okay, it's safe to move to the next uh, cell in that direction. For example, here is safe will return true, and in all these three it will return false. So if is safe is returning false, it means that those sides can contribute towards your parameter. In that case you will increase it, and yeah, you will keep doing these things for all the cells in the grid, if those cells are land cells obviously, and at last you will be returning your perimeter, which is the required answer. Okay, so now thinking about the complexities, as far as time complexity is concerned, you might have seen that we are just traversing the whole grid only cell by cell. So it will be nothing but order of number of rows into columns, which is number of cells. Okay, and as far as space complexity is concerned, you might have observed that we are not using any extra space here. This whole function is working in constant extra space, and this array that we are using to go into directions is of constant size. Okay, so which is by the way 4 into 2. So we are not counting it. It is not varying with respect to the input size of the grid that we are getting. So space complexity wise it's constant, order of 1. Okay, so these are the complexities. This is the approach, and a little you know optimization you can do is that you can take reference here instead of because this operation will result in making a copy of direction entry being made. So instead of making a copy, you can use this ampersand symbol. So this is the approach, and if you are still having any doubts or any queries in general, you may ask them in the comment section. I hope this problem solving session and this solution video or solution walkthrough provided or added some value to your journey of owning your DSA skills. And please remember that consistent practice is the only way to master DSA. And till then, keep practicing, keep coding, and I will see you in the next video. Thank you for watching.